Okay, so thank you for the opportunity of having us here and conveying some information regarding this year's RecSys challenge. First of all, let me say a few words about this year's sponsor and co-organizer. RecSys is a Polish company. We specialize in recommendation systems. But what's maybe a bit unusual about RecSys is that our approach is we strive to be more task and data agnostic. Our approach is we apply more universal approach in recommendation systems. I will explain it in a detail on the next slide. This also is related to the goal of to the main task and subject of this year's RecSys challenge. So this allows us to collaborate with many industries, a variety of companies. Okay, so let me now say a few words about what was this year's RecSys challenge about. So the task was universal behavioral modeling. Please focus on the left-hand side of the slide. It depicts a typical scenario. So we have some data. Usually it's user data, and typically we don't have a single task. We have a bunch of tasks. So what we do, we craft several models. Each model is dedicated for a given task. If there is some new task, then we need to create another model. Then we need to maintain all these models. So data is also non-static data changes. So then we need to update all those models and so on and so forth. On the right-hand side, you've got a scheme which presents you a universal behavioral modeling. So there are two key differences here. So first of all, there's this intermediate step. There are these profiles. So the idea is that you take data and you extract information from this user data in order to create user behavioral profiles. And you want to do it in such a way that these profiles are task agnostic and as universal as they can be. It's hard to define. And then the second difference is that you've got very small and fixed architecture, and you use the same architecture or very similar and small architecture for all of these downstream tasks that you have. So in case of the RecSys of this year's RecSys challenge, this architecture was actually a very small feed-forward neural network, and the architecture was the same except that the output differs because the tasks were different. But so the last layer was basically different for each of the models. And now if you have a new task, then it's quite easy. You take these universal profiles as inputs, and you take your architecture and you train it for this particular task. Okay. So participants were asked to submit these universal behavioral profiles. On our end, we used our infrastructure to evaluate those universal behavioral profiles against 6 tasks. So the tasks were separated. So 3 tasks were known. It means that their definition was known in advance for the participants, and 3 tasks were hidden. So participants were only able to access the scores that they achieve, but they do not know in advance what's the specific definition of the task. So this hidden tasks was, the idea was to further enforce this universality and task agnosticity constraint of the challenge. Obviously, we also released the dataset now. It's publicly available. It's quite large data set. It's very sparse. Mostly it contains implicit interactions. You don't need to necessarily use it for universal behavioral modeling. So it's more like a general purpose data set. Yeah, it's a very large real world interaction data, quite noisy. So I think the broad research community, I encourage you to use it. Maybe it will benefit you. So yeah, that would be it.
Yeah. So I will provide a bit of insights from the statistics of this year. So if we see this graph is the red bars are the number of submissions for the challenge. We had around 4,100 submissions. That means that this was one of the most popular challenges in the last years. We had 436 teams. Among these, around 300 were active throughout the whole challenge, with around 600 participants. We also want to highlight that thanks to the sponsor, we had also 3 academic prizes that were awarded only to participants from academy. This was to ensure that academic teams with less resources could also compete for some prizes. And we had over 100 academic teams coming from more than 40 universities. Participants spread from many countries in the world, of course, mostly USA, China, India, Japan, Korea, but also from European Union and UK. Very quick look at the most popular methods that were mostly based on ensemble methods that aggregated in different ways feature embeddings or factorization machines and GRU autoencoders. But we also want to highlight a couple of more original approaches. One was based on LLM that were creating narrative user profiles that were then used to generate the embeddings, and another that focused on the task agnostic hybrid action variational encoder that basically did not focus on optimizing for the task of the challenge, but just to have the most abstract and adaptable user profile embeddings. The winners, we had, as I said, 3 industrial track winners. These are the names of the team. Rec2, AI Lab, RecSys, and Sense Lab, but also 3 academic winners. Embed and Breakfast from Politecnico di Milano, UAEC Bootcamp 2025 from University of Electrocommunication Tokyo, and Ririka from East China Normal University in Shanghai. One thing I also want to highlight is that the call for challenge proposals for next year is out. You can find it on the challenge website. There are many participants from industry. If one of you has an interesting idea, you can have a look at the call, and maybe if you want more details, you can approach us. And then I want to thank again the sponsor, Syneris, for being so fantastic in supporting the participant throughout all the challenge. The other chairs, Abby, Marco, and Claudio, that did an amazing work. And also Prof. Janak, that give us a lot of support in the whole challenge organization. Thank you all, and also thanks to the participants that made this year challenge very successful. Thanks.